So you've heard about me talking about hundreds and thousands before. Soil carbon is a big store, and that's why there's a fair bit of talk that you only got to change it a little bit and it makes a big difference. So that's assuming the country's in A condition. If we discount that to the various land conditions, we actually, and we're assuming that you only change the carbon in the top 10 centimetres when you change land condition, because the carbon below 10 centimetres actually starts getting old, very old. You can actually drop your soil carbon stock on your property down to 930,000 tonnes of carbon dioxide equivalents. So you're missing about 93,000 tonnes of carbon dioxide equivalents on your property just from having it a lower than optimum land condition. Okay, how's that going to change? And this is again, you start having to assume numbers which may be useful, but you've got to run your eye over to see if they actually make sense. So we assume that we could change 70% of the C condition country to B condition over 25 years, so through improved grazing management or other practices, improve that land condition. You actually increase your soil carbon stock to 950,000 tonnes, which is a gain of about 800 tonnes of carbon dioxide per year. Can this be done? There's really no data to actually say whether it can be or not. And part of the current soil carbon projects is going out to Toorak Research Station and looking at the utilisation trial there to try and answer some of those questions. Conversely to that, if your country gets hammered a bit, then soil carbon is very resilient. Pushing it hard in 1 year is not going to make much difference. It's long-term overgrazing is what declines soil carbon, not just 1 year of a drought or such. So, but what happens if soil condition actually declines? So you can very quickly have a massive number there if you knock your land about quickly and the soil carbon declines. So if we destock the property, we've still got the same starting soil carbon amount, but how does that soil carbon change with destocking? And again, there's almost no research on this at the moment. There's a little bit that is available. We can consider two options. In some work that was done looking at the soil carbon content in surface soil between exclosures, so putting a fence around and keeping livestock out in the grazed area, they showed over 9 exclosures that there was a 7% decline in the soil carbon in the exclosed area. So where it's exclosed and the grass has become more abundant and essentially can be unhealthy, you can actually possibly be reducing soil carbon. So I'm going to use that as one example. And you might say if you exclose for 20 years, how long is it going to take to decline to that? So I've assumed 20 years. So if that was the case, the soil carbon would decline to 907 tonnes of carbon dioxide. So it's a loss of 1,350 tonnes per year. Another assumption is that you destock the property and the land condition actually improves. So if the land condition goes back up to 70% A condition, 20% B and 5% C condition, over a time frame of 50 years, that soil carbon builds up. So that's actually a gain of carbon sequestered of 1,180 tonnes per year. Can this be done? At the moment, the measurements haven't really been done, so it is conjecture. But it gives you some idea of what the magnitude of some of these changes may be. Another area which is got almost no data for northern Australian grazing systems is what's the magnitude of soil emissions. So when you have a soil that gets waterlogged, you see the shelf soil goes sour, it emits nitrous oxides and things like that. So there's almost no data in Queensland, but if you look at a global review of savanna soils, they showed that there was a net emission of about 0.26 tonnes of carbon dioxide equivalents per year per hectare. And that's made up of an emission of nitrous oxides about 0.28, but actually a sink of 0.2 of methane. So that's actually the soil absorbing methane. And part of the problems with termites is termites emit methane underground, but as that methane's percolating up through the soil, a lot of that is actually captured back into the soil. So that's part of the complicating factors of trying to measure what the methane emissions are from termites. One thing we don't know is what's the impact of management. If you destock, does it make any difference? Does it go up, down? Is there any impact? In this case, in the way most analyses are done at the moment, because there's just no data and there's no indication whether management has any impact at all, and it's just regarded as one of the background emissions of the planet, we assume there's no impact from management. But if you actually multiply that number up, it's quite large at 3,600 tonnes of carbon dioxide equivalent. So it is a big consideration of what might actually be included or not included in the future. So let's start to put some of these numbers together. So the top line there is methane. So you had 2,600 tonnes on the grazed property, nothing on the destocked property. Have your energy emissions of 112 versus 28. Savanna burning emissions of 119 versus 1,015. And the total emissions are, for adding those lot together, which is probably the most similar to some of the Kyoto type analyses you see, would be 2,800 for the grazed and 1,000 for the destocked. So there is still more emissions from your beef country just based on those emissions. But depending on what you assume happens with soils and your livestock, it actually is what really makes it a critical argument about which one's better than the other. Another point is the soil emissions are there too, the 3,600, and I haven't included them in the emissions, but that's the background level of what those emissions are. So if you look at livestock offtake, you can take off 200 for that. Your trees, depending on what you assume the tree's going to do, you can either have some sequestration in the grazed, or if the fire's going to knock about the trees on the destocked, you might have a decrease, so it might be emissions or about zero. And the soil carbon, depending on what you assume, whether you're going to improve land condition or land condition may decline. So you can see from the size of those numbers that depending on what outcome there, it actually makes a big difference to what the actual final outcome is for that block of land. And I'm not going to add them together, you can make your own judgment on that and whether my assumptions are correct, but it gives you some idea what the magnitude is and what potential it may be. So that's just those emissions in the graph form. So you've got livestock methane, the savanna burning, you've got no vegetation clearing, you've got your property energy, and you've got your livestock turn-off, so also vegetation biosequestration, so that's, you need to add, depending on what you'd use for the destock property, what line bar that would be, and the soil emissions. If we just look at the total biomass stocks, so we've got livestock biomass of 580 tonnes. The grass and forage biomass is 65,000 or 109,000. So your livestock biomass are a very small proportion of the carbon that's on your property. You look at the trees again, depending on what you assume there. At the moment it's 128,000 tonnes. And the soil carbon is much larger in scale again, it's the 934,000 tonnes. So the total biomass you're actually managing on these properties is 1,130,000 tonnes. So it's a very large number actually, with the pool of carbon that's there, and we're doing little changes around the edges, so that's why it's so hard with the measurement.